In the last video, we talked about how chemical bipropellant rocket engines work. This is essentially a process of converting the chemical energy that is contained in the propellant into forward movement, or thrust. However, there are lots of recently developed propulsion techniques which could be used as alternatives to this chemical propulsion technique. Let's take a deeper look at some of these more advanced propulsion technologies and see what could be powering the rockets of tomorrow. There's an excellent chart which can be used to help compare different types of rocket engines in terms of their efficiency and their power. The two parameters that are essential on this chart are what are called specific impulse, which essentially measures the efficiency of the engine, and the overall thrust, which is showing how powerful the rocket engine is. First, let's explain specific impulse. This may seem a bit complicated, but you can think about it in terms of a unit which is describing how fast the exhaust is coming out of the rocket engine. The faster the exhaust gases are able to leave the nozzle, the bigger the push that those gases can give to the rocket, and the more thrust it will have. We engineers call this phenomenon impulse, and it's basically working on Newton's third law. For every action, there's a reaction. Therefore, specific impulse is describing how much push or impulse each individual unit of mass is giving to the vehicle. This essentially is a unit which is telling engineers how good of a job the propellant is doing at pushing the rocket forward. As a simple analogy, specific impulse is a little bit like the mileage that your car gets, except for rockets. Maximum thrust is a little bit easier to understand. It's essentially just the maximum throttle range that the engine can produce. What's the maximum push it can impart on the rocket? Coming back to the car analogy, this is a lot like the maximum torque that your car can give if you put the accelerator all the way down. The chemical engines that we looked at previously fall roughly here in the chart. As you can see, they deliver a good amount of thrust, but they don't really deliver a whole lot of specific impulse, which means they're not really that efficient. So, are there more efficient engines that might be out there? The whole world is going electric because it increases the efficiency of the things that we do every day. It turns out that rockets are also going electric for similar reasons. Instead of using chemical reactions in order to generate the energy to make the thrust that makes the rocket go, electric propulsion uses electric fields to accelerate atoms which have been ionized to really high velocities. Usually these systems utilize gases which are called noble gases. They come from the rightmost column of the periodic table. These gases are easy to charge through a process called ionization, in which an electron is essentially stolen from the atom so that it now has a positive electric charge. This ion can then be accelerated through the electric field, which will push it faster and faster and faster, kind of like a railgun. Once it exits the electric field, it will recombine with the electron at really, really high velocity and impart the momentum onto the spacecraft. The velocities which these ions can reach can be up to 50,000 meters per second, which is 10 times more than traditional chemical rockets can achieve. However, all this efficiency does come at a cost. Unfortunately, because of the energy-hungry ionization process and electric field, it takes really high amounts of energy in order to power these systems. Because of the high power requirements, these thrusters have a hard time competing with the thrust levels of traditional chemical rockets. This makes them not really useful for launch services. Usually the thrust provided by an electric propulsion system will be on the order of millinewtons, which is virtually unusable for most human purposes. However, for a small spacecraft, that small amount of power over a long period of time can end up in really, really high velocities. For this reason, they can be quite useful for small missions. One key spacecraft that used electric propulsion was the Dawn spacecraft. This was a mission to the asteroid belt in which the spacecraft was able to visit 2 separate asteroids. This would be something that a traditional chemical rocket would not really be able to do, because usually they deliver all of their thrust all at once at the start of the mission. But because Dawn was able to keep its thruster on for the majority of the mission, it was able to visit both Ceres and Vesta and get some incredible images. Maybe one day in the future, when there are more powerful energy sources available, we may be able to use this type of propulsion in human applications. Maybe what we really need is a bunch of super high power charging stations built by Tesla to help us get there faster. Tesla's in space! The problem with electric propulsion is that we don't really have a power source that's strong enough in order to power the electric thruster to meaningful power levels. But wait, We already have a super powerful energy option in nuclear energy.
We have the technology.
Why not just strap a nuclear reactor to the rocket so that we have lots of power to power our ion thruster? This is exactly what the developers of the nuclear thermal engine were thinking back in the 1960s when development on this idea started. A nuclear thermal rocket can take advantage of the nuclear power source by flowing a fluid through the core of the reactor in order to pick up its heat. This hot fluid can then be used as the exhaust as it expands out of the nozzle, and it can actually deliver a lot of energy to the rocket. The typical working fluid that is utilized for these applications is hydrogen, and when it gets really hot as it passes over the nuclear reactor, it can pick up a lot of speed, which makes it a really effective propellant in a nuclear thermal application. In total, these rockets can have 2 to 3 times more efficiency than chemical rockets. This would place this type of rocket somewhere here on the chart. This is actually one of the options that was being thought of in order to power the rocket that was going to the moon. However, to achieve these higher velocities, you actually need to have a really hot hydrogen gas. To date, there is no material which can contain the high temperatures that the thermal reactor would be imparting onto the hydrogen. So in order to compensate for this, you actually have to reduce the temperature of the hydrogen in order to make this application actually effective. This means that the overall specific impulse improvement that you would get would be at most only 2 times what we get out of chemical rockets. But that's still kind of a lot. But this isn't the only thing that's holding back the nuclear thermal rocket. As you might imagine, anything related to nuclear technology needs to be really safe. Because the nuclear thermal rocket is relying on a nuclear reactor, they do run the risk of irradiating things around them if there's a failure. Of course, this makes us mere mortals a bit nervous because chemical rockets don't exactly have the best reputation for being 100% reliable. Yeah, so that was banned back in the 1960s. And progress on those types of engines really haven't developed since then. But maybe we can come up with a way to make these types of engines more reliable. Or maybe we could use these nuclear thermal rockets as a space-only type of application. There's still the risk of getting the nuclear thermal rocket into space, but this could be actually an engineering challenge that could potentially be solved. At this point, nuclear thermal propulsion is one of the most promising technologies that could enable interplanetary travel for humans, if only the political will was there to unban it. What if I told you that there was a truly ancient technology which we could use to traverse through the solar system? And the best part is, we wouldn't even need engines at all. Or propellant. Maybe the answer to effective interplanetary travel has been right in front of us the entire time, hiding in the past.
No.
This is where the concept of the solar sail comes in. The idea for a solar sail comes from the sail that we use on a boat, which is able to convert the mechanical energy of the wind and push the boat forward. Well, it turns out that the sun also produces a wind of sorts. This wind is essentially charged particles that stream off of the sun's surface. We might be able to harness this wind in order to move our rockets forward in the same way that the wind moves the boats forward. The best part is that this form of propulsion is theoretically infinitely efficient because no propellant is utilized in the process. However, there are a few drawbacks. In the first case, the sun's solar wind is actually not that dense. So you actually end up having to use a really big sail in order to capture enough of the solar wind that will push you forward. The solar wind is not so dense, so capturing it requires giant sails, which could be kilometers in diameter, just to propel a very small spacecraft forward. This presents a bit of an engineering challenge because in order to have a solar sail that's effective, you need to have a light spacecraft. But you also need to have a sail which extends over a giant radius. So to achieve this, we need to have very thin sails made out of special materials which are able to be stretched across those distances and still be mechanically sound, while also needing to pack all of that sail into a very, very small box so that we can launch it on our rockets.
Phenomenal cosmic powers!
A mission called LightSail actually was able to demonstrate this technology in 2015 and 2019. They designed this particular mission to have a sail of about 32 meters squared, and it all was able to fit inside of a small CubeSat that was only 30 centimeters by 10 centimeters by 10 centimeters, which is essentially the size of a suitcase. That was some pretty impressive packing that team ended up performing. Due to the success of this mission, there are a couple of missions which are potentially going to use a solar sail in order to power their interplanetary trajectories in the future. So those are some interesting technologies which have been developed recently in the realm of propulsion. Do you think we missed any? Drop us a comment if you think there's something that we didn't cover that you think is important. If you like the video, subscribe and click the bell. You can't miss the next video. And remember to expand your horizons.